if the volume of a cube is x cubic feet, so the volume of the cube is x cubic feet, and the total surface area, so the total surface area of the cube is x square feet, then we are asked to find the total length of the cube's edges, So like I've done in the past videos, I told you that anytime you are given any question that has to do with geometry, it is always best you give a diagrammatic representation of what the question is depicting. So since we know that the question is actually talking about, or is a problem that concerns a cube, so what I'm going to do is I'm going to sketch a cube here. So we know that this is how a cube looks like. You have something like this. So let's say this is our cube. We have this down, and then this down. So there is one thing that is peculiar about cubes, and what's the thing? The thing about cubes is that both the length, the breadth, and the width, they are all the same thing. So if I'm going to represent, since it's a cube, I'm going to just call my length, I'm going to call all of them, I'm going to call them all, I'll call them L. So it's a cube, so they are all the same thing. But if it was a cuboid, then you can't expect them to all be the same thing. But since it's a cube, that is, it has a square base, and all these here, they are all squares. Anyway, we already understand what a cube is. So let's begin to depict what the question says. So I need to give a mathematical representation of the statement. So what it says here in the first statement here is the volume of the cube is x cubic feet. So the volume, so we have the volume of the cube. Now we know that the volume of the cube, or the volume of a cube, is given by length times breadth times height. So and that is L cube. This is the length, this is the breadth, this is the height. So we are told that the volume is x cubic feet. That is, this is equal to x. So the cubic feet you have here is just the SI units, that is ft cube, and then x square feet is just the SI units x square feet. So do not interpret this as x square feet. Now this is wrong. So it's just x is what you need. Alright, so let's go back to what we're doing. So we are told that the volume of the cube is x cubic feet, and then it says that the total surface area of the cube. So this is for the first statement. Now for the next statement, it says the total surface area of the cube is x square feet. The total surface area. So I'm going to call that my total surface area. So what's the formula for the total surface area of a cube? Now when you look at this cube here, you'd observe that the cube has how many faces? So we can count. This is one face, that is 1. This is another face, this is 2. Then the one at the back, that is 3. Then the one here, that's the one next, that is 4. So we have this is one face, which we have done here. This is another face, 1 2 3 4. Then we also have the top face, that is the one on top, that is the top here. So which we call we'll call that 5. And then the bottom is 6. So all in all, the cube has 6 faces, and then all the faces, they all have equal areas. And then since we know that if you pick one of the face, that is, if you have this, and then this is L, so the area of this square, like we know, is just length times breadth, so the area is just L squared. So if you're told to find the total surface area of the cube, now since it has 6 faces, it has 6 of this, so definitely the total surface area is going to be the sum of all the surface areas. And then since we have 6 of them, the total surface area is just going to be 6L squared. That'll be 6L squared. So, and we're told that the total surface area of the cube is x square feet. That is 6L squared equals x. Now I'm told to find the total length of the cube's feet. Now before you continue, what you'd observe is that you have like 2 equations. So let's call this equation 1, and then we call this equation 2. So in these 2 equations, you'd observe you only have 2 unknowns. That is, you have one unknown, you have two unknowns here, so it implies this is a simultaneous equation. That is, when you solve these two equations simultaneously, then you can find L and you can find X. But assuming you had three variables, then you need three linear equations to uniquely find each of the variables. Alright, from what I have in equation 1 and equation 2, when I subtract equation 1 from equation 2, that is equation 1 minus equation 2, what you would have is, so this is going to be L cubed minus 6L squared, L cubed minus 6L squared equals X minus X, which is going to give us 0. And then L is common here, so you can bring L out, so you have, L squared is common in the two of them, so you have L remaining here, negative 6, and then you can close the bracket, equals 0. So you can solve this. So this implies that either L squared equals 0 or L negative 6 equals 0. Now if L squared equals 0, this also implies that L equals 0. Or when you solve this, you have L equals 6. So we have two solutions for the length of the cube. But then when you consider this solution, it is not possible for the length of a cube to be of 0 feet. So this is impossible. So the one which is possible is L equals 6. So based on the two equations we have been able to find the length to be equal to 6 feet. So we are going to use this information here to find the total length of the cube's edges. Now if I ask you now that it says what is the total length of all the cube's edges, now how many edges does the cube have? That is the first question you need to ask. So if you can know how many lengths the cube has, then since we know that each of the lengths, they are all the same thing, then we can just multiply them by the total length. So anyway, I'm going to resketch the cube again that we have. So what we had was, this was our cube. Let's say this is the cube here, and then we have something like this. So just something, this is just a sketch. So we also have this. So what we want to do now is we want to count the edges of the cube. So looking at it here, so the first one is, you can see here, this is one edge, so we'll call that 1. Then this is another edge, so we'll call that 2. Now this is another edge, so we'll call that 3. So this that we have here is another edge, so we'll call that edge 4. So we keep on going. Then this is another edge, so we'll call that 5. This is another edge, we'll call that 6. This is another edge, we'll call that 7. Then which again do we have? Okay, yes, we have this is another edge. Let me use something else. You have this is another edge, so we'll call this 8. Then yeah, we also have this is another edge. This is blue, so we'll call this 9. So we still have some left, so we have to go around all of them. So this is another edge, so we'll call that 10, while this is another edge, we'll call this 11. So I guess it's one left. We have just one more left. Yeah, and then this is the last edge, so we'll call this 12. So all in all, you can see that we counted all the edges of the cube, and we see that they are actually 12. So what the question says is that what is the total length of all the edges? That is, we're told to sum the length of this. So you know, for each of these each of the cubes, their length is L. For each of them, the length is L. So to find the total length of the cube, all we need to do is we need to just multiply 12 times the length of each of them, since they are all the same thing. So since each length is 6 feet, so the total length is just going to be 12 times 6, and which is just going to be 72 feet. So the answer to this problem is 72 feet. So that completes the problem. Thanks for watching.